The broadcast is now starting. All attendees are in listen-only mode.
Hey, good morning, everyone. It's David Prangnell here with Leica Geosystems. With me is Jaron Hopfe. Hopefully, I'm saying that right.
You are
The
right.
last name, anyway. Yeah. So with me here is Jaron. We're going to do a quick presentation today on the reality capture solution, field to finish, as a combination of Leica Geosystems and MicroSurvey Software. Working with laser scanning and that sort of thing. We're going to focus on two pieces of hardware in particular, the RTC360 and BLK to go. And Jaron's going to show us some really cool stuff on what to do with that cloud data in MicroSurvey CAD Ultimate. We might give people just a few more minutes to get logged in here. Our numbers are a little light, so if we'll just hold tight for a minute or two. I think
Call your friends, get them to join.
Yeah, call your friends, tell them to log in. I think we're going to hold all questions till the end, Jaron, or are you okay with questions during?
Well, it's up to you for during your presentation. I don't mind questions during. If you got any questions, just type them in the chat bar at the bottom of the GoToWebinar. There's a little drop-down thing where you can hit that, and then you can send the questions to the entire audience or directly to us. And Dave will keep an eye on that when I'm presenting, and I'll keep an eye on that when he's presenting.
Yeah, I'm like you. I don't mind questions during. In fact, it's kind of nice because a lot of the times I know I've attended a lot of webinars in my day, and I get a question in my head and I forget about it by the end, and it never gets answered if I don't remember somewhere down the line. So feel free to punch them in the chat. We'll try our best to get to them as soon as possible. And if we don't notice it for a couple slides, we'll be happy to rewind a bit to get to your question. So that being said, maybe we'll get started here. I'm gonna start this off with the field side, being of course a field to finish solution. I'm on the hardware end, so that's usually where people start. Not only are we going to cover hardware, though, we're also going to look at the Register 360 software, which is the necessary software for your scan data to quality control, quality assure, register, and there's some really neat and helpful tools in there as well. So let's get started. Like I said before, I'm Dave Prangnell, for anybody who's just logging in. With me is Jaron Hopfe from MicroSurvey. I'm with Leica Geosystems. I'm the reality capture sales manager in Western Canada. So that's a fancy title for the laser scanning division. I oversee Western Canada, so I work with our resellers to provide solutions and to help our customers. So what we'll be covering on the hardware end today, or let's take a quick overview, I guess, of what this hardware entails. We've got the BLK 360, which is this guy down here. I'm going to turn on my laser pointer. The BLK 360, which is the entry-level laser scanner system, along with the RTC360 and the P-series systems. Now with the P-series, we have the P40 and the P50. The P30 has been discontinued, but the P40, P50 are fantastic laser scanners covering the higher end. On the good, better, best, we're going from BLK 360 to RTC 360 to P-series. What I wanted to talk about today is the RTC 360. Reason being, it is the most latest for terrestrial laser scanning, the latest release for terrestrial laser scanning, and it's probably the most popular scanner on the market right now on the Leica division for terrestrial. So it's a good reason to have a chat about it. Now that being said, if you do have questions on the other two scanners, you can put them in the chat. If I feel it's pertinent to what we're going to talk about today, I'll be happy to answer it. If not, I might take you offline and we can have a discussion there. So real quick, this is the spec overview for all of these scanners. Starting with the BLK360, you're looking at very fast imaging speed, good scan speed for a small unit. If you've ever seen a BLK360, you'd probably be very surprised at the size of it. It's just this tiny little thing, very light, very portable, very versatile. Some of the drawbacks of it, of course, is it's got a short range and the 3D data quality isn't as good. I'm looking here at the bottom of these specs. And that's to be expected. It's an entry-level scanner. It's what you get started with. The RTC360, however, is a little more robust. You're getting a better range, a typical range of 40 meters, a max range of 140. I tell my customers to keep it under 80. That's kind of the effective range of it. And you're getting a better 3D data quality. You're also looking at a much better speed. You're looking at a full 360 scan on low resolution in 26 seconds with the RTC360. One thing I should also address here while I'm talking about these is the field registration. Tying your scans together in the field differs greatly between each of these scanners. The BLK360 does it through a software base. It happens in our app. You do a cloud-to-cloud comparison, and the scanner will process a link between your two scans. The RTC360 can do this on the fly. It's what's called a viz-based system. Basically, it tracks itself as it moves. When it comes to the P-series, we're looking at the best quality of 3D data, and we're also looking at the best range. This max range is a little out of date. I just noticed this now. That would be closer to what the P30 offered. The P40 and the P50 can actually go up to upwards of 500 meters and above, which is fantastic range. But your field registration is going to be done by surveying procedures. I think the majority of the people here have a survey background. At least if you're coming from the MicroSurvey end, of course, you have a survey background. You're setting up over a point, you're traversing with a P-series. Those functions are not available in something like the BLK360 and the RTC360. It's tracking or field registering, I should say, based on cloud-to-cloud comparison and registration. Also, the one thing I should mention here is your resolution. So something like the P-series can get sub-millimeter for a high resolution. So you're getting a point at points between each other at less than 1 millimeter apart, whereas something like the RTC is you're looking at a few millimeters at high res. And like I said before, we're going to talk about the RTC today. Also, like I said before, the RTC is probably my most popular scanner. I get more inquiries on it than anything else because it is the newest and because the technology is really quite amazing, to be honest. When I first saw the RTC360, I was blown away. So yeah, that's the reason why we're taking a look at it today. So let's talk about the RTC360 and its laser scanning functionality. Bottom line is it's fast. It's really fast. Like I said before, at low res, which is a 12 millimeter at 10 meters of distance, at a low res scan time, we're looking at 26 seconds for a full 360 scan. 1 minute, 26 seconds if you want to add images to those. So it'll take a full spherical image of its position, from its position, I should say, in 1 minute. So you're adding 1 minute to that scan time. And then as your resolution goes up, so does your measure rate. And of course, as your resolution goes up, your range is going to come down as well to keep that 3D point accuracy where it needs to be. But again, even at the highest resolution with imagery, you're looking at less than 3 minutes for a full scan, full 360 degree. I should comment on here as well. So this is resolution. This isn't 3D point accuracy. It could be very easy if you're looking at just specs to get those confused. That's 3D point accuracy isn't resolution, obviously. Resolution is going to be the number of points per area. 3D point accuracy is how accurate those points are. So something like the RTC360, you're looking at a distance of 10 meters from the scanner. You're looking at about 1.9 millimeters of 3D point accuracy. So picture a 1.9 millimeter bubble, and your point is going to be in there with confidence. Of course, that expands as you get out from the scanner all the way to at about 40 meters, you're looking at about 5 mils, a little over 5 mils, 5 and change millimeters at 40 meters from the scanner. So still a very effective range. In fact, I read somewhere that Leica did a pretty comprehensive study that asked its users, how far away are you using your scanner? Like your area of interest is here, your scanner's here. How far away is that distance usually? And the answer came back that 80% of the time that distance is 30 meters. So if people are scanning at 30 meters, this is a more than effective laser scanner for anything that needs to be sub-centimeter. How are we doing for questions there, Jaron? Anything?
You're good so far.
Good so far. Okay, good. Let's talk really quick about the spherical images. So what we're seeing here on the screen is a kind of a spec or a diagram of the RTC360 and its insides. The area colored in orange here, modeled in orange, is the HDR cameras. Less than 1 minute, or it is 1 minute to collect a full HDR dome, independent from light conditions. This is HDR imagery, so it can be varying light conditions. It can still process a photograph or an image that is decipherable. Very high dynamic, bright sunlight, darkness. There's no user settings attached to that. It's automatic. It detects the light conditions and adjusts automatically. And the colors are represented as they are. So when it takes that image, that spherical image, it takes the color that it received in that and applies it to your point cloud. So you're getting the colors as they are represented in the real world. The thing that really makes the RTC360 unique, in my opinion, is this system. It's called the Visual Inertial System, or VIS for short. What it does is it actually tracks the scanner in between stations. So when you scan once, you pick it up and you move it, the VIS system kicks in, and you're able the scanner itself tracks its position as it moves. It watches where it's moving to. Also, it has an IMU attached to it that tells it, that it's moving, where it's moving, what kind of speed, that sort of thing. And there's no real interaction needed there. It's auto start and stop. So if that VIS system is turned on, and there is a switch to turn it on or off, I'm not sure why. I don't know why you'd ever want to turn it off, but as soon as you pick up that scanner and start moving, the VIS system kicks in and starts tracking its own position. Very robust, handles subtle nuances of surrounding features. I think that's important as well. So what this looks like, so we've got a pretty nice diagram here of what that looks like as you're scanning. So I've got my scanner set up, I've got a scan, and I've got a point cloud. I also have a VIS system turned on, and this is what my VIS system sees, those 5 cameras. So if anybody's keeping count right now, we've got 5 cameras on the VIS system and 3 on the HDR imagery. So we've got a total of 8 cameras in that scanner. 5 of them for the VIS system turn on, and they're actually watching the environment as it's sitting in its place after it has done its first scan. So when it compares that to the point cloud, it's going to start picking up points, and it's literally watching these points with its camera. So you can see on this this slide where those points are in comparison to where they are in our point cloud and our VIS image. So now when this scanner has related itself to those points, it gets picked up and moved. It tracks itself watching those points. And I know that we've got like 6 points here. In reality, it's much more than that. So the scanner gets picked up, it gets moved, goes to its new setup position and scans again and picks up new points, new 3D points created by the forward intersection from multiple scan positions. So we've picked up new points based on the scanner's movement. Again, we're moving, and it's going to track not only its original points, the ones it can still see, it's going to track the new points as well for the third position. And I've got a really cool video. I think this is really cool anyway. I'm a geek for this sort of thing. So I've got a really cool video on what that looks like. So this is the first 5 cameras here. These 5 here are the Viz cameras. These are the cameras that are on the RTC360. This one, this camera position, is actually somebody walking next to the RTC360 as it's being moved. Now it has scanned these areas and it has point data for all these areas. And you can see some of these points are showing up green, some of them are showing up blue, and some of them are showing up red. And what that means is the green ones, it's very confident it's able to track that point. Blue, it's not so much sure, it's not so sure it can track that point. And red is points it's trying to track but having a difficult time with it. So let's go ahead and start this. There's no audio to this, it's just straight visual. So I can narrate as we go. So the RTC gets picked up. You can see this guy walking here. He's the one with this camera over here, walking next to the system. And you can see as the RTC is going, it's following these points, tracking them as it moves through this Viz system. So they actually walk through a tunnel here. It follows itself along. You can see through the tunnel, it's got a lot of these red dots kind of flashing up, flashing out. What that means is it's trying to track some points. It's a little difficult in the tunnel sometimes. So it's not having a very easy time of tracking those points, but it does have green points it is following to keep its position. And now when they set it down at the next setup, it's actually tracking itself. There we are. And you can see the users are looking around in their environment to see what they're able to scan next. So,
I've got a question here, Dave.
Sure.
What kind of distance can you get between those 2 setup points? Just as long as it can see something from its original scan?
Depends on what you want to do. If you want to easily link or do a cloud-to-cloud link or registration between those 2 setups, it's good to have at least 30% overlap between your 2 scan positions. That being said, you can go as far as you want and scan again. And if you want to do an in-field link, an in-field registration, you're going to want that 30% overlap. If not, and you want to try and link it some other way, you can go as far as you like. Does that make sense? Did I explain that well there? Okay. So True RTC. What this is talking about is just bringing all these 3 things together. The laser scanning, the imagery, and your inertial system, your Viz system. So we're looking at up to 2 million points per second. Highly dynamic, more measured points on critical surfaces. So you're getting points on, black plastic, getting points on things that have poor reflectivity. Acute angles, that sort of thing. And you're looking at a fast imagery, 1 minute for a full HDR dome. And then the Viz system, with those 2 in mind, the Viz system helps you track that delta pose between your 2 setups. And no user interaction. There's no button to push to start your Viz system. As soon as it gets picked up and moved, away you go. If you're worried about having to hit a button and forgetting to hit a button every time you move it, it's not required. It's automatic. So that brings us to the overall RTC360 solution. I know I'm introducing another factor in this slide that we didn't really discuss, which was the Cyclone Field 360, which is a very handy app that can work on iOS or Android for controlling the RTC360. It is not required, however. Everything, you can operate the RTC360 fully on the control pad. It's just a matter of picking it up and hitting that play button, and away you go. the two work great in conjunction because you will actually be able to see your cloud data inside the app as you're scanning, and say there for whatever reason it's unable to link your two setups automatically, you're able to do a manual link if it's possible inside that app. So I strongly recommend the app. I really like it. I think it's probably one of the best selling features of the RTC360. What this all goes down to is or the way we're processing all this data is once that raw data is collected, you're taking it to Cyclone Register 360. And we're going to get into Register 360 in a minute. What Register 360 is, for people who don't know, is the processing system. It's processing your links. It's adding additional links. It's coming up with statistics to tell you how well your data is comparing to your setups are comparing to each other. And you're also publishing your data with Field 360. And we'll get into that in 1 second. The other thing I want to touch on real quick before we do is the newest member of the Leica Reality Capture bundle, which is the BLK to Go. Now, I don't include this in the terrestrial side because it is a mobile unit. It's not terrestrial. You don't set it up. You turn it on, you start walking. Very, very advanced piece of hardware. It actually has a lot of similarities with the RTC360, believe it or not. Things like an IMU will tracks its movement, but it is a SLAM unit. SLAM meaning simultaneous location and mapping. And there's two different SLAMs. We're getting a LiDAR SLAM, meaning it's actually using LiDAR to gauge its distance, to measure distances. And using a visual SLAM. There's 3 cameras on board that are doing the same thing, very similar to what the RTC is doing. It's watching its position as it goes. So it does have a lot of crossover in a mobile type unit as opposed to something terrestrial. Putting all those pieces together, those 3 features together, we have what we call a Grand Slam. So with Grand Slam, we're looking at panoramic imagery, your LiDAR scanning, and well, the Grand Slam technology is your LiDAR SLAM and your Viz SLAM. You're also collecting panoramic imagery as you go. So much like the RTC360, it's able to apply colors to your scan data. Put it all together, and you've got a powerful data capture in a handheld instrument. I do have a demo unit of one of these. I have been playing with it quite a bit, and I think it's just a really cool piece of technology, to be perfectly honest. So that brings us to Register 360. And the reason why I say this brings us to Register 360 is that both of these hardware products process their data in the same software, Register 360. But not only do the BLK to Go and the RTC 360 process their scan data in this software, BLK 360, which is the smaller terrestrial unit, also processes in Register 360, and P-series data can now be processed in Register 360. So we're using one package to process and register all our data and export. So that obviously means that you can mix your data. You can scan with a BLK to Go for the interior of a commercial building or something similar, and then scan the exterior with your P-series and process it all together, georeference it all together, which we'll get into here in a second. First thing I wanted to show off with Register 360 is how we create new links. What I have here is a project in Reg 360, and we need a link between 2 setups. So before we jump right into that, though, I do want to discuss how Register 360 operates. It's very user-friendly when it comes to working with your scan data. It's basically a 4-step process. We're importing our raw data. We're reviewing, optimizing. This could also be called registration QA/QC. We're finalizing, meaning checking all of our results and showing that we're happy with them. And then we have the 4th step called report. I feel like they could call this report and publish, or publish and report, something along those lines, because that's the most important part, is what data we're going to get out at the end. Because it's really nice to have a project with 16 million points in a per setup. I think this actual project has over 100 million points. But what do you do with it when you've got it, right? That's always been the age-old question, I think, when it comes to reality captures. Okay, great, I've got all this data, now what? So first thing I want to take a look at in this is using Register360 for link creation. We're linking 2 points together, also called registration. And for this particular piece, we're going to link these two setups together. And it's just a matter of clicking on one, shift-clicking on another, and picking how you want to link these together. You can match targets together, you can do a split view, or you can do a straight-up visual alignment. So what I'm doing here right now is just looking at the two different scans. We have two scans, one's in blue, one's in orange, and we're visually putting them together. Just aligning them together so that we can tell, where one scan ends, one scan picks up, and how they meet together for this registration, stitching them together. So it's always nice to pick up on things like building lines, fence lines, that sort of thing when you're processing your or linking your scans together. That's looking pretty close right there, getting lots of good overlap. We've switched. That was a top view. We switched to a side view, and this is where we're going to make our roofs and streetscapes, stuff like that, all line up. That looks pretty good. We have a lot of links already in this project, so that's a pretty simple link to create. Not all of them are that easy, obviously, but there's our overlap there, 30%. That's what makes for a nice link. And there we have it. That's how we link together two setups inside Register360. Now that we have those linked together, I'm going to go over one more tool. There's quite a few tools inside Register360, and I wish I had time to go over all of them, but obviously we have to, I don't want to keep you guys too long, so we're going to go over one of the most common ones, which is called the limit box system. So limit boxing is just taking out slices or chunks of your data and ignoring everything else that you don't need. So I'm going to take a limit box out of this cloud. I'm going to my bundle cloud view, and I just want those sails. This is for anybody who knows. This is the iconic Kelowna sails in downtown Kelowna, BC. I scanned this a little while back. I think it made for some good data. Say you wanted to model these sails and you just needed the sails themselves. Well, I just created there. I went to a menu, created a quick limit box. Picked on the sails, and I just have to adjust the box now to get the data that I want. Revolve it around, take a look, see, expand it a little bit here, shorten a bit there. Make sure you're getting what you need and nothing extra. Adjusting these boxes is actually really quite simple. It's just a matter of picking on a side and dragging on it. You hit the shift key if you got to pick a side of the box that's behind something else. So in this case, I hit that shift key, I click on that side of the box, and I rotate it or slide it up, and I can save it. Hit that save button, and I've created a limit box. I go in and recall it or rename it sails, and it's saved, and away we go. When I click that export button right there, that means it will export in with my exported data at the end during the publish phase. Now there's also a manager, so I could create multiples of these limit boxes throughout my project for any data I need. And I don't need to see the box either. I just turn off the visibility on it, and there we go. We have our sails. Now all our other data, all our other point cloud data is still there. We're just not viewing it. This is not capturing a piece and then deleting everything else, which you can do, by the way. But just taking a chunk out and taking a piece of it out and using that effectively. So the next thing I wanted to highlight in Register360 is something that I know all the surveyors in here are asking right now, and that's about georeferencing. Georeferencing and control, because surveyors, modelers want a cloud. and they want that cloud to match up to the way they think it should work. Surveyors need things geo-referenced. They need real-world coordinates. So I'm going to show you how we accomplish that in Register 360. So I'm going to open up a project here called House and Targets. It's one I've already processed, but I just want to show you what that looks like after we've geo-referenced our data. So here is here's a house that has been has some control points attached to it. So a surveyor friend of mine actually came and surveyed these points in. He just fired up a GPS rover or GNSS rover attached to SmartNet and tied in a few points, a seam in a driveway, an edge of a catch basin, and a couple spikes in the backyard. So we set targets over those points. And when I scanned, the scanner picks up on those targets, and I'm able to apply a coordinate to those targets. So there's 2 out front, 2 in the back. So what we're looking at here is each of those blue circles is a setup of the scanner, and each of those purple pointers is pointing to a control point. So when we went through, I went through and scanned this all, made sure the targets were visible at most of my scan stations. You can see I scanned from several different points in the backyard here. Yeah, a few different points, exploring the data a bit, and just exploring what that target looks like. So there's a spike in the ground there. I don't know if we can make it out in the scan data, but there's a spike in the ground that was placed there by the surveyor, and it's been scanned with that target. So these targets are automatically recognized as well. When I bring this data in to Reg 360, I can have it automatically recognize black and white targets. So it creates that target node immediately. So now, say I need to find a couple points on this house, I can adjust again my limit box just for convenience sake, not having a bunch of cloud data to have to worry about. Say I needed just these corner points on this house, and I wanted to find out what the coordinates attached to them are. Create that limit box, maybe overdid it a little bit there. Zip it back, there we go. And we'll turn off the visibility on it. Let's rotate our data a bit. Let's see that corner of that garage. Back up a bit, and let's pick a couple points. Turn on our points button, and we pick a point on that garage, and you can see it's georeferenced. We have a UTM coordinate attached to that. We can do that on either corner. And of course, you could do something like this as long as it's georeferenced when it comes into CAD or whatever field to finish solution you're using, like MicroSurvey CAD Ultimate. You'd be able to pick on those coordinates and get a real-time coordinate for that. Turn off our limit box, and there's our points on our garage, and there's our georeferenced point cloud. So next thing, so we're back to Register 360 here, and you can see that we've gone from our view and optimize, presumably through our finalize, and onto our reporting. Again, I still think this should be called reporting and publishing, but I didn't write the software, so some engineer in Switzerland did. So anyway, this is our options for publishing. The most common file types for publishing I have found in my experience are going to be the LGS file, and we'll get into the LGS in a second, and E57. E57 is kind of a universal cloud type. E57 can go into many different software packages that want to work with a cloud, or RCP. RCP is an Autodesk file type that I think almost all Autodesk products can accept to bring cloud data in. The LGS file is a Leica proprietary file type. So this file type can go to many, or not, I shouldn't say many, I should say all. It goes to basically all Leica file or Leica software programs that deal with point clouds. So things like Jetstream, we can talk about Jetstream in a second. Jetstream, CloudWorks, TrueView, they all take an LGS. Even Register 360, if you have an LGS from somebody else, you can drag and drop that into Register 360 and take a look at what their data looks like. This slide talks about Jetstream, And there's a lot of confusion around Jetstream, and people have a hard time understanding what exactly it does. So this LGS file is great because I can take this LGS file that I've created or exported from my Register 360. I can hand it off to my friend Jaron here, and he can throw it into his Leica software or his MicroSurvey software, and he can work with it. He's working with my cloud, which is fantastic. Well, say you don't want to add, you've got 5 technicians that need to work with the same LGS, and you don't want to hand out 5 different, 4 gig files because point cloud files can be large. That's where Jetstream comes in. I compare it to being the Netflix of cloud data. When you work with like when you watch a movie on Netflix, obviously you're not downloading that movie. You're streaming it. So that's what Jetstream does is you set up your own Jetstream system, Jetstream server. You take that LGS, you throw it onto Jetstream, and now everybody attached to that Jetstream server has access to that LGS, and they're never downloading it. They're putting it into the background of their program. And we can see how that works with MicroSurvey CAD here in a second, or how that gets brought in. But there's a ton of ways to work with this LGS file now, that it's either handed to you or streaming to you through Jetstream. It can go into everything from AutoCAD to Revit, SmartPlant 3D, and MicroSurvey CAD Ultimate. We've got MicroSurvey CAD Ultimate right down here. So lots of different ways to work with that cloud data. And to answer that age-old question, I've got all this data now, I've got all this point cloud data, what do I do with it? Well, this is exactly what you do with it. You create this file and you start handing it to people who can use it. People who are using something like MicroSurvey CAD Ultimate. And I think that's where I'm going to hand it over to Jaron. Any questions on that? I know I can get rambling pretty fast, but did we see any questions there, Jaron?
Nothing new on this end. No, I think you're doing good so far.
Okay, and I'm going to hand it off to you.
All right, thank you very much. And I'm going to make sure I'm showing the right screen here. We're looking at the webcams here, Dave. Presentation.
I'm seeing your presentation. Sorry, I'm not.
Yes. Okay. Yeah, we're looking at the right screen.
Yeah.
Yep. All good. Okay. Thank you, Dave. I just wanted to introduce myself a little bit here as well. My name is Jaron Hopfe. I'm the desktop survey product manager here at MicroSurvey. So that means I look after MicroSurvey CAD, as we're going to talk about here in a second. I look after development on StarNet, which some of you may be familiar with as well, and then our AutoCAD-based products in CAD and embedded CAD. Just applying surveying functionality to those products themselves. We have 5 different product levels of MicroSurvey CAD available. That's the product that we're going to discuss here today. We've got basic, which is going to be your just basic CAD entry and a survey entry. So this would be kind of like your land surveyor sitting in the office checking plans and stuff. It's really only meant to be a viewer. Sorry, my slide's not progressing here. What's going on? There we go. We've got standard, which includes all of that CAD functionality and all editability, as well as least squares adjustments and background imagery. We've got premium, which includes surface modeling and corridor and pad modeling. Ultimate is where we start to see the point cloud import. It's got the clipping, snapping, and bare earth extraction from the point cloud. And then we actually have a studio version as well, where it'll allow you to create animations and fly-throughs and that sort of thing, if that's something you'd like to do in your point cloud as well. We offer our products on a perpetual license basis, which means you buy it and you own it. No subscription necessary for that. We do have a maintenance subscription if you'd like to continue to receive updates. After that initial purchase, it's a fraction of the cost, though, so you do not need to pay the full price every year. We lock our system down with USB keys. This keeps it secure and keeps that license yours. But we do have network licensing available if you're wanting to run it as part of a corporation, where you have a server and a few licenses and you want everybody to have access to those. Supported formats for point clouds, we pair with Leica Cyclone and Jetstream, as Dave mentioned there. We can easily import point clouds from most sources through that E57, the LAS, and PTX formats. And those will go straight through Cyclone Viewer. There's no additional purchase necessary for that. As a benefit of being a hexagon company, we have direct access to the Leica LGS format, which imports instantaneously into MicroSurvey CAD rather than going through the Cyclone Viewer. In addition to that, we have access to point clouds from Captivate projects, which might have been created from a Leica MS60 or something like that, where you get a scan as well as your total station data, and that comes directly into the program as well. But that being said, if you have a version of Cyclone Publisher, then it doesn't need to go directly through, or it doesn't need to go through Cyclone at all. We import directly into MicroSurvey CAD as long as that license of Cyclone Publisher is detected. Now, there's different applications for point clouds that you can use in MicroSurvey CAD. These are requests from you. So I tried to tailor this a little bit to show you how you can create each of these different things. We've got topographic surveys. You can easily and quickly create topographic plans in MicroSurvey CAD, and I'll show you that in a minute. Real property reports, as-built, volumetric surveys and road design, and profile views. So point cloud tools. These are the things that you're going to use in MicroSurvey CAD to work with that point cloud data and turn it into something useful. One of the primary functions that it seems fairly straightforward, but not every software does it. It's point cloud snapping. We use the node snap as part of the CAD engine to snap directly to individual points in the program. That means you can draw lines, circles, polylines, 3D polylines, etc., directly on the point cloud. And if you really don't feel like clicking on the point cloud, if you're trying to snap to CAD objects, you can turn that on and off with a single click. It doesn't need to be on all the time. To make it a little bit smarter and a little bit easier to use, we also include the Smart Pick viewport. I'll go over that here. That is this screen here. It modifies the point snap to allow you to select a location, and that being the highest point, the lowest point, the closest point to where you are currently located with your cursor over here, or the calculated ground point. So in this location, what I've got selected is the lowest point, and I'm selecting along this corner here, and it's actually creating a point snap down at the bottom of the point cloud there where would be the ground, rather than the calculated ground point. I'll go over that in a minute. But this is actually quite powerful and allows you to select various locations in your point cloud very easily, especially when you pair it with UCS and some of the different tools that are available there. One of the other things that this does, it allows you to show alternate angles. So if you've worked with point cloud data before and have needed to select points within the point cloud, it's very easy to say, click here, but then have it select something back over there. So this Smart Pick view here, and I'll show this a little bit later as well, it'll rotate through, oh, it's got to be a half dozen or more different views, different angles in the project, so that you can really be sure of where you're clicking before you select that point and make that commitment. Being CAD line work and polylines, it's very easy to undo what you just did and re-click anyway, but there's nothing more annoying than tracing something and then rotating your view and finding that half of it is all on something else. There's smart UCS tools in MicroSurvey CAD as well that we use to easily align the UCS. So if you're not familiar with that, that's your point of origin here. You can align those very quickly with 2 clicks between a floor and a wall intersection. So if you wanted to place it here, say if you wanted to do some work on this wall here, trace the door or the window or something like that, a wall-to-wall intersection. So again, 2 clicks here and here to put it on the intersection between those 2 walls. Along a slice, a wall plane, or between 2 points are different options as well. Once you've done that, there's a single click swap. Sorry, I got to speak English here today. Single click swap between plan and elevation view, which will allow you to easily switch between drawing flat on a wall or drawing a footprint for a building or something like that. Points on grid. This is how we extract surfaces in MicroSurvey CAD. You'll select a grid spacing. You'd pick your grid display. So what I've done here is created a 3-meter topo grid over that surface. You select a fence. You can select a rectangular fence, polygon fence, or a circular fence, depending on the area that you'd like to apply those points to. And then you select the location that you'd like to apply those points to. So as in the previous Smart Pick viewport, you'd select the highest, lowest, closest point, or ground. Typically, I think you'd want to select ground in this location because then you're going to get that computed ground surface for the whole thing. From there, you can use the surface modeling routines in MicroSurvey CAD to turn that into a tin model, average the surface with the gridding, or turn it into contours for your topographic plan. Limit boxes, we have those just like in Register 360 that Dave was showing you. You'd apply a limit box just by clicking on the limit box function, select a couple of corners and then a height for it. So what I did here is I actually selected a corner on the ground over here, corner on the ground over here, and I'm in the process of raising it up here. What that turned into was this, which isn't quite ideal because it doesn't show the ground there. So we've got a single click inflate or deflate function, or you can, like in Register 360, modify the height, depth, or width of the limit box to make sure that it encompasses all of the data you're looking for. The clipping tools. This is how you isolate the area you want to work with. We've got rectangular clipping, which will allow you to obviously select a rectangle. This will work in any view. You don't have to be top down. If you're looking at this from the side, you could apply it just like a limit box where you'd kind of draw the rectangle around it that way. We've got a circular clipping, and you'll notice that this one is opposite. Any of these are clip within the rectangle, or circle, or polygon is the next one, or clip outside. So what I've done with this one is this is clip outside so that I can work with the data inside it, and what I've done with this one is clip inside so that I can ignore those cells. Or the very best one, in my opinion, is the polygon clipping tool, which allows you to select the specific area that you want to work with. In this case, this pad for these sails here. Slices are another very powerful tool for working with this data. When you factor in the point cloud snaps, this makes profiles and floor plans very easy. You'd easily be able to, with 2 clicks, create this slice here so that you can draw this profile of the house that Dave was going over earlier. Same thing, 2 clicks, you can create a slice through the Z-axis or a Z-axis if you're American, to turn this into a top-down floor plan type view where you can trace the house, you can trace the fence and the shed in the back here, you can see the trees, the shrubs, etc. Hot tub in the back there too. One of the other things that's really powerful for this is the slice forward and backward utility. So that allows you to, as you can see in the picture here, slide the slice forwards and backwards. It works really great for footprints. It allows you to find that sweet spot where you see all of the information that you're wanting to see and none of the stuff that you don't. Sections are another way you can look at your data and work with it. What that will do is it'll draw a line through your point cloud and clip everything on one side of it, but not on the other. So this is drawn straight through the center line of the roof of the garage here, looking at that would have been the east side of that house. So that it's now a profile view of it, but you can also see the window in the house and the tree in the back. And if I had my picture a little farther, you could see the fence coming out the back of it. Same thing for the elevation view. Now we've got the footprint of the house and the hot tub and the shed, but also you can see the tree, we can see the deck, we can see the patio, and all of that additional detail. These are all managed through the Clipping Manager. This is a utility within the program that allows you to turn on and off those clips and modify them. Every clip you make is stored. As I mentioned, you can turn them on and off. You can create groups of those clips and apply those groups, so you can have like a house group or the neighbor's house group, or whatever you want to create there to manage your drawing. And you can modify the slice thickness from there so that you can show more detail or less detail in that slice. Sometimes it makes the walls a little more apparent if you increase the thickness of that slice. And one of the other things you can do is you can invert that clip. So I've got the work area for that house here, but say I wanted to look at the rest of the neighborhood and create a surface for that, the contours for it, or whatever. You can invert that clip very quickly just by clicking on the checkbox. I'd like to move on to a few more advanced tools now. True Spaces being one of those. This is similar to the view in Register 360 or the app that Dave was mentioning. It allows you to look at the scan locations in the project, select nearest to a click in the point cloud. So if you're wanting to look at the scan by the front porch here, you just click on the point cloud near the porch here and it pulls this up. You can review the geotags. This is images and things that are saved in the LGS file. You can navigate between the stations. There's an overview where you can pick each of the different stations that you want. Or if you rotate around in here, you can actually see a red dot where the next station is. The drawing view, when you rotate around in this true view space here, will update as well. So if you can see it here, you can see it here, and you can draw on it. And you can apply quick limit boxes if you want to work in a specific area. So what I've done here is I created a 10-meter limit box, and I picked in the point cloud here, and it isolated that area for me to work in. This is very good if you're working in a very dense area and you kind of have to navigate your way through visually through the scanned stations and then apply that limit box. Silhouette mode is another newer utility in MicroSurvey CAD. This brought across from Register 360 as well, I believe. And what that'll take is it'll take something like this, where we've got a standard slice of that front of the garage there. So say you wanted to trace the garage doors and the roof line and all of that. If you apply the silhouette, it'll actually bring out the edges of those automatically. This makes a good deliverable, or you can, it makes it easy to trace. If you don't have it sliced, however, it'll actually show you all of the extra detail through the entire point cloud without needing to slice it and move it up and down. So you can see the wall line here, but you can also see the roof line and the chimney and then the deck and the garage doors, and all of that detail is actually retained through that silhouette mode. That I think would work very good for a profile view. Say you had to put this on a plan and show all of the data on that site, you could turn this into a deliverable very quickly, and you wouldn't need to slice it and move that slice around so that you can get each of those individual items. It just shows it all right here. As I mentioned, allows you to create fast deliverables, create or trace multiple layers simultaneously. Sorry, I forgot to click through my presentation there. Something here I wanted to go over a quick little workflow on a real property report. Say we wanted to do that for this house. First, we want to isolate the work area. That's a rectangular clip around the area that I want to work on. And actually what I did is I turned it into an elevation view, and I clipped off the top of the trees so that we could see those a little more easily as well. If you notice, there's the trees. Now I've clipped them off so I can see the house. We want to add or calculate line work. So say we've got our calculated subdivision and the points that were shot in the field. We add that. Apply a section through the middle of that house so we can get the footprint and the shed in the back, as well as the fence around it. trace it and add the blocks for each of those things. We've got the shrubs coming up the front, the 3 trees in the front, the 1 in the back, deck, patio, footprint, etc. And from then, it's just dimensioning and finishing touches. One of the things that MicroSurvey CAD does very well is we track survey points and dimensions and bearings and distances between those. So this is very, very easy to add. All of the house ties, we have tools for doing that. And that's one of the benefits for using MicroSurvey CAD right there. You can turn that point cloud into a deliverable. I did this in a matter of, must have been 15 minutes. It does not take long at all. So for point clouds, that's really powerful. They're quite a lot of data. So to turn it into something useful in that amount of time is very nice to do. Wanted to mention, if you purchase MicroSurvey CAD before June 30th, we are offering 10% off of it as well. I wanted to do a live demo here. I'll just pull up the program. And Dave wanted me to show one of the scans that he had done with the BLK to go. So we're going to pull that in metric project. How are we doing for questions, Dave?
No questions so far. Yeah, we're good.
Awesome, thank you.
Yeah.
Okay, so as I mentioned, we've got plan view, and I can switch it to elevation view very quickly. We've got 2 floors of this building here. I'd like to clip outside the rectangle. Oops, sorry, I right-clicked there. Make sure I get all of the information. We'll go after that top floor, and we'll cut the roof off of it.
I know, sorry, just for time's sake, I'll be real quick here, but this data is actually the interior of a commercial building. It's actually the office building where MicroSurvey CAD is located, or MicroSurvey, I should say, sorry, MicroSurvey Software is located. I had the opportunity to scan an office on the lower floor, and then I got to scan MicroSurvey at the upper floor. So this is BLK to go data. This is all mobile. I think I did this whole entire building in about 15 minutes with the BLK to go.
Okay. Thanks, Dave. So now we can see we've got the floor here. We've got all of the walls and stuff. And I'm actually going to clip that a little bit further here. Maybe I'll make a slice out of that. I do the clip outside rectangle again. I'll do that. I've got an elevation, or a plan view, sorry. And that's all the data. If I want to move that slice forward and backwards, I can just click this. I was just doing this with the host data, sorry. I don't know if it's something to do with the BLK to go data or what is going on exactly, but that will move that data up and down. And now from here, I can, sorry, if I click that plan view a couple times, it just gets it back to the right place. Now I can just start tracing around inside the building. Say I wanted to get my office, which is over here somewhere. Now we'll go for our boardroom.
I think I actually walked in the boardroom. I didn't walk into individual offices, so there might be better data. Might be better data in the boardroom. In fact, I think I snagged a geotag there too.
Inside the boardroom. Okay, well, let's take a look at the true space here.
We are coming up on 1 hour here.
Yes, sorry. I will wrap it up quickly.
No,
I just wanted to show something with movement that wasn't a slide to a presentation here. Of course, my computer's chugging along because we're doing a presentation. Sorry, everybody. This is why I wanted to avoid a lot of live stuff on a live presentation, because point clouds take a long time to do things.
It's true, yeah, and that's why the crowd probably noticed that all my software stuff was recorded, just because broadcasting over the internet, plus working with a point cloud, you know, it's pretty taxing on a system. Yeah.
So here we've got our geotags, as Dave mentioned. These come through in the LGS file, sorry.
What a geotag is with the BLK to go, there's a one button operation, and while you're scanning, if you hit that one button, it will actually take a photo from the camera forward facing, and it stores that as what's called a geotag. So it's a georeferenced photograph of a georeferenced photograph in your project. Sorry, that's
fine.
Yeah, just had to explain.
No problem. I believe this was done while we were all in COVID lockdown, so everything is empty. But yeah, that's how this works. I'm gonna turn off the perspective view again here, and we'll pull it back into plan view. And I can just create a polyline, start drawing just like it's regular CAD. Pull up the Smart Pick viewport here. I might need to update my version of Cyclone. Sorry, I was putting this together on my other computer. So, okay. Another reason to stay updated. Okay, so I'm not going to go over that. We've reached our limit here anyway. So I think I'll just wrap it up here, and we'll call it good unless there's any further questions, Dave.
I haven't seen anything yet.
All right.
Yeah.
Okay. Well, thank you very much, everybody. Sorry, Dave, did you want to say something?
I was going to say, if there are questions going forward, feel free to reach out to me or Jaron. Happy to answer them, you know, after the fact. And, you know, we can get hold of either one of us, you know, through the MicroSurvey office, or I'm with Leica. And I believe my email address is attached to my profile here in the webinar information. So.
Yes, I believe it is.
Yeah.
Our office phone number, if you'd like, is 1-800-668-3312. This recording or this webinar will be recorded and posted for you to get back at that if you like. So, thank you very much, everybody.
Okay. Thanks, everyone.
Have a great day.